Hi guys, welcome to another episode of MrLopezClasses.com. In this episode we are going to talk about marine radars and how the radar is integrated with the NMEA backbone and how the radar is integrated with the GPS and how the radar is integrated with the autopilot system. The autopilot systems work together with the GPS and with the radar. Those elements work together like a robot. I explained to you at the beginning of this book. And this is the last chapter of our marine electronics books. I hope you enjoy this book, the same that I enjoy preparing these episodes for you. I want your backup in my webpage. I want that you write to me with more suggestions, more recommendations for the future videos. Thank you. Thank you for your patience. I hope that you learn. I hope that you enjoy these videos. Okay, we are going to continue with this chapter 18, related with radars. And we are going to start to talk about a simple, I start all my chapters exactly the same. I try to find a simple definition. In some cases, it's my own definition. In other cases, it's the definition of other guy, like today. But I try to do my videos simple, easy, funny, and this is the idea. Because today, learn is easy because you have a lot of information in your cell phone, in your computer. Okay, definition of radar. The primary function of the radar is collisions avoidance, especially during the night when the visibility is too low. This is the function of the radar. Help to the captain, help the pilot in order to move the boat, to drive the boat in the evening, in the dark, because in the dark you are blind. It's like a tunnel. Like a tunnel, dark tunnel. Alright, radar detectors work like radio receivers, picking up specific frequencies used by the radars. Specifically, radar guns used by police officers are used to identify and catch speeding cars. Captains need to be able to maneuver their ships with some small distance in worse scenarios, in worse conditions, and they navigate blind during the dark, during the night. This means inside of dark, with no visibility, they need to safely navigate their way through waters in worse scenarios, in worse conditions. Okay, we are going to check what is the meaning of radar. Radar is radio detection and ranging. Was developed in 1940 by the U.S. Navy. Radars are rarely used alone. They work together, like I explained at the beginning of this episode. The radars work together with the autopilot system, with the GPS, and they are integrated, the radars are integrated with the NMEA backbone. Don't forget, this is very important. Today, in the NMEA backbone are integrated all the electronic devices that we learn in this class and other additionals, because it's not only the electronics equipment. You remember the picture that we have on the screen? In that picture are integrated engines, generators, water makers, VHF radios, all the equipments that you have in your boat today. The equipments can be administrated, can be operated by your cell phone directly, because those equipments are together incorporated into the NMEA backbone. You remember the procedure to connect those equipment. How much is the maximum amount of devices recommended? Yes, no more than 50. No more than 50. How much is the maximum total distance of the backbone? Depends on the cable. Remember, for mini or for micro. For mini cables, the maximum distance is 250 meters. For microcables, 100 meters. About the drop lines, how much is the cumulative of all the drop lines together? The maximum, 78 meters, correct. And how much is the maximum distance of each drop line? Yes, it's 6 meters, no more than 6 meters. What is the procedure to calculate the maximum total distance? The maximum total distance? Oh, the maximum total distance is the distance in between each terminal resistors plus some drop lines, especially if that drop lines, the distance is bigger than the distance in between the T and the closest terminal resistor. All right, this is very important, and I want that you keep in mind that information, because this is the only information that you need in order to take the National Marine Electronics Installers. Yeah, that's the certification that we are going to take, and you are ready right now to take that certification. Other important information is about the maximum intensity in the backbone. You remember how much is that? Is 8 amps, no more than 8 amps. And you remember the recommendation about to connect devices directly, the power of those devices directly into the backbone. This is possible only for devices that the consumption in amps be no more than 1 amp. How much is 1 amp in terms of length? Is 20 lengths, okay? All right, because each length is 50 milliamps. All right, and what happens if the equipment need more than 1 amp? Oh, that equipment should be connected into a sub-panel, DC sub-panel. Examples of equipment that normally are connected not on the backbone, the power, not the data. The data is to the backbone, the power of those equipments into the sub-panel. Yes, the VHF radio is one example. Other example is the radar, because the radar have a mechanisms, electrical mechanisms to move the radar. Yeah, like the radar that we have on the screen right now. That mechanism, the consumption is 2 amps, 2.5 amps, should be connected in a breaker on the sub-panel, not on the backbone. Yes, the data on the backbone, but the power on a separate breaker on the sub-panel. That's important. Other example of other equipment that should be connected with a separated breaker. Probably you remember the power assisted unit in the autopilot? Yes. Power assisted unit or drive unit or electro-hydraulic unit. No, it's exactly the same name. Yes, those equipments, if those equipments use more than 1 amp, they should be connected directly with one breaker separated on the sub-panel and not on the backbone. The power, not the data. All right, this is the summary of this class. It's not complicated, it's simple. And how can I avoid introduce more than 8 amps in my backbone? With fuses. Remember how many sources of power can you install in a typical backbone? Depend on the length of the backbone. Normally one power in the middle, one source of power in the middle, and other 2 sources of powers on each end, depend on the length. But in total, no more than 8 amps. How can I limit that amount? With fuses. Suppose that I have 2 sources, one at the input and other at the output. I am going to install one fuse of 4 amps in the input and other fuse of 4 amps in the output, and I will be 100% sure that I have 8 amps in my backbone. That's very, very important. This is critical with fuses. It's simple. You remember about the sources of power? There are 2 types of sources of power, directly from the batteries or rectifiers with a constant power. Yeah, those rectifiers, if you supply the power for the backbone with the batteries, all of the sources should be from the batteries. If you supply the power to the backbone with those rectifiers, constant sources of power, all of the sources of power should be from rectifiers. Never mix. Simple. This is basically the theory related with that. And right now we are going to finish with the theory to install the radar. It's exactly the same. The concept is exactly the same for all the equipment. We are going to repeat quickly. Is the sensor For example, remember in the previous video, the transducer of the sensor, the transducer, the cable is the sender, and the computer and the screens are the instruments or gauge. Okay, the instruments, the sender, and the sensor. Simple. All of the equipments have the same protocol. Let me explain, let me remember the autopilot. Yes, the autopilot have the computer of the autopilot. You remember that one on the screen? You have the screen of the autopilot, and you have the sensors. How many sensors you have in a typical autopilot? You have the radar sensor, you have the gyro, the compass, the hidden sensor, and that's it. Those are the sensors. And other important equipment is the servo cylinder. The servo cylinder, all of those equipments are connected with the central computer, and the computer is connected with the main screen. Simple. Other electronic device that we are going to connect to the NMEA backbone. This is the autopilot. The other one was the transducer. The radar that right now I am going to explain is exactly the same. We have a sensor, we have the motor, we have the computer, and we have the display. It's exactly the same. All right, and now we are going to continue. Okay, the definition is clear. The working principle. How is the principle used to calculate the distance in between the sensor and the object? What is with what principle, what physical principle is used to calculate that distance? Yes, the principle is the Doppler effect. The Doppler effect that we are going to explain right now. The working principle of a radar is simple. It uses electromagnetic waves, and the radar consists of a transmitter and a receiver. Those are the elements, the transmitter and the receiver. The transmitter transmits radio waves which bounce when the wave found an obstacle and return into the receiver. That's simple. The distance of the object is calculated using the simple formula of speed is equal to distance divided by time. Speed is equal to distance divided by time. Yes, and we are going to use the speed of the light. How much is the speed of the light? The speed of the light is 886,000 miles per second. With that formula, this is the speed of the light, and with the time, I am going to calculate the distance from the object and the receiver. The receiver is the equipment that you have in the tower of your boat. This is the simple formula, and with that formula, the equipment internally, the computer of this equipment calculate the distance. You don't need calculate that. You don't need with your scientific calculator. No, the computer internally in the radar calculate that distance for you, and you have on the display the information related with that equipment. If the equipment is too close to the chip, you have a warning light indicating that you have in the proximity one element too close to the boat, and you can steer the boat in other direction. Right? This is exactly the procedure. All right. The basic principle of operation of a primary radar is simple. The theory is a little more complicated. The implementation and operation of primary radars involve a lot of disciplines. A lot of engineers, a lot of genius are involved in this project. Let me explain how many people. Of course, mechanical engineers, electrical engineers, microwave engineers, advanced high-speed signals, data processing, and other laws of physics and chemistry. It's a lot of people, intelligent people integrated, but basically are computer engineers, electrical engineers, and mechanical engineers. Three disciplines together in this business. Once again, electrical engineers, mechanical engineers, and computer engineers. Those three branches of engineering dedicated to design the robots. Okay, I hope that you understand that if you are a good mechanical engineer, if you are a good electrical engineer, if you are a good computers engineer, it's easy for you to transfer in order to be a successful naval engineer or naval architect. Yeah, I recommend if you want to be a naval architect, I recommend that you be primarily a good mechanical engineer. The mechanical engineer involve the rest of the disciplines, believe me. Okay, my friends, we are going to continue the reflection of the signals. The electromagnetic waves are reflected if they meet an electrical leading surface. Yeah, basically the signal bounces when the signal found the object and return into the receiver on the radar. Right now I am going to explain how the radar works when the radar is operating, send signals and receive signals, sends signals and receives signals. Electromagnetic energy travels through the air at constant speed. What is the speed? Okay, the speed is 300,000 kilometers per second or 800,000 miles per second or 162,000 nautical miles per second. This is basically the same. Normally the people use 300,000 kilometers per second for terms of calculation. All right, basic principle of operation. This constant speed allows the determination of the distance between the reflecting objects and the radar, basically with the distance and the time. Okay, this is the source of the power. This is the object. This is an stationary observer. And the signal travels in one direction and they are bounced in the other direction. And with the formula velocity equal distance divided by time is calculated the distance, because we know the velocity of the velocity of the sound, the velocity of the light, and you know the time. And with those elements, you calculate the distance. It's very, very simple. This energy normally travels through the space in a straight line, and will vary only a little because atmospheric weather conditions. By using of special radar antennas, this energy can be focused in a specific direction. The direction is related with the azimuth. And the elevation is with respect to the ground, and the azimuth is with respect to the axis north and south. That's very important. All right, in this picture you can see, okay, this is the elevation angle with respect to the ground. This is the elevation angle. Nice. And the azimuth is this angle, the deviation with respect to the north and south. This is the azimuth. Yes, this is elevation, and this is the azimuth. Perfect. The basic information that is provided by a radar is the bearing and the range. From this, everything else is calculated, including position and time. Application of radars. There are millions of applications of radars. Today, the majority of the intelligent cars, intelligent vehicles, they have incorporated a radar. And with the radar, they calculate distance. The majority of the safety features in the new cars is because those cars have incorporated a radar, and the radar calculates the distance in between your car and the next car or other objects on the way. The first basic use of a marine radar was in military. Always. The military engineers, they discover the majority of the equipment that we have in our hands today. The radars, the GPS, the tracers was discovered for the militaries 50 years ago, 40 years ago, 100 years ago. And right now, those elements are popular on the people. It was used to locate sea targets. Today, they are used for the Navy to locate specific targets. To find out the bearings and distance of ships is necessary prevent. They are used to prevent collision in between ships and collision in between ships and objects. Application of radars on ships. The radars are used to navigate and determine the course of the ship. They are used to fix various positions on the sea with several fixed reference, such as islands, buoys, lightships, and other objects on the sea. They are also used to measure the waves on the surface of the ocean. They are used to see the traffic. They are used to determine the weather, especially during the storms, during the hurricanes, in order to verify, in order to predict the weather. The radar is a very, very, very important equipment. Okay, and how is the troubleshoot of the radar? But in order to explain the troubleshoot of the radar, I want to explain before of this how the radar works and how we are going to connect the radar. For that reason, right now, I am going to explain that procedure.
Hi guys, in this episode, I am going to explain the procedure to connect a radar, the technical procedure to connect a radar, and some tips to connect a radar. Normally, this is the part of the radar that is located on top of the flybridge, on top of the tower. Should be located in a clean area. No obstacles here, no obstacles over there, because here and here are located the sensors. Those sensors emit an infrared signal each some milliseconds. And this element is spinning. It's spinning always and sending those signals. And those signals for Doppler effect bounce and return according with the time spent in that travel. This element calculate how much is the distance. This is the effect Doppler that I explained before in the previous part of this episode. Okay, once again, this is the sensor. Inside of this element is located the sensor, and the sensors have one emitter and one receiver. One emitter and one receiver. And this is the function of this element. Is plastic. Plastic. Never try to cover with aluminum foil or something like this, because it's plastic and the signal passes through the plastic. Alright? This is the sensor, and in the bottom is located, let me remove this one, is located the electromechanisms. The electromechanisms internally have the computer, and the computer is connected with the main screen of the boat. Right now we are going to talk about that. Alright, this is the electromechanisms. This is the mechanism that is spinning all the time when the system has power. Is recommended each 2 weeks. Verify with your hands when the system off. Verify with your hands if the mechanism is working clear, with no sound, in good conditions. All right, internally in this electromechanical device, you found that the mechanical system have belts and gears. Those belts should be properly tied according with the manual. Check the manual always and verify that the mechanism is working properly and the belts are in good condition. Those belts are broken sporadically. For that reason, you need to verify that the belts are in good condition, the tensor in good condition, and if it's necessary, replace the belt. The belt can be replaced. You order the kit for this radar, for this unit, and you receive the kits and you receive the gears in order to replace the gears and the belts. If you don't have experience with this equipment, don't try to fix it. Other important element in this electromechanical equipment is this gasket. This gasket should be in perfect condition in order to keep internally the radar completely dry. The humidity is the enemy of the computer and the central unit of this equipment. This gasket should be in good condition. Never added silicone. Never, under any condition. The gasket should be clean and should be properly inserted on the slots. There are slots in order to keep the gasket in the position. Okay, the cable with the power and the signal communicate the electromechanical element and sensor with the computer, with the central unit. This is the main screen of the boat. That's the main screen. In this particular case is Raymarine, but the other manufacturers are the same. All right, this cable, the cable in this end, in the end of the screen, have two terminals. One terminal with the pins, that terminal enter in the back of the computer in the position radar. And the other one, positive and negative, is for the power, positive and negative into the DC panel, into the DC sub-panel. Be careful, because this equipment, depending on the manufacturer, the consumption is more than 5 amps. Be careful with the breaker for the radar. Be careful with the breaker for the radar, because the breaker should be properly calculated according with the gauge of the wire and the distance of the cable. You remember the formula that we use, or the table in the ABYC study guide? Okay, we are going to use that formula and install a fuse. A fuse before the power enter into the unit. Be careful. You need a fuse and a properly breaker on the cable terminal. All right, this is this end, the end of the screen. In the other end, the cable have the positive and the negative, exactly the same, coming from the DC panel, and this one with the data. If you check the diagram here, the diagram have the color code purple, orange, blue, yellow, green. Those cables should be connected here in this slot, one per each slot, and at the end the slot enter here and make a click. When the slot enter over there, right now those cables are connected according with the color code, and right now the data is incorporated. This is the computer and this is the screen, and both of them are talking the same protocol. Be careful with the order of the colors according with the diagram. If you make a mistake in one color, probably the equipment doesn't work. Okay, recommendation. Before you introduce each wire into the terminal here, I recommend soldering the wires, and after that introduce here. And when you have all the cables inside of this, you introduce this element into the slot, and right now the computer is connected. Very important recommendation. Other important recommendation is this case should be isolated, should be properly isolated, or if it's necessary, connect one of the bolts in the bottom, connect one of the bolts to the bonding system in order to avoid future problems. Why? Where is located that equipment? On top of the boat. If you don't have the rod appropriated install, this one is your draining. For that reason, I recommend connect the body of this equipment directly to the bonding system. This is an important recommendation. Connect the body of this equipment directly to the bonding system. And those are the most important recommendations. Periodically move the mechanisms of the radar and check the condition of the belts and the gears and connect appropriated according with this, and be careful with the fuse.
Okay, about the troubleshoot, this is the procedure. The first step, remember, we have the computer. The computer in this particular equipment is located inside of the electromechanical element. And you remember the cable with the different colors and the procedure to connect those elements in the computer. That's the computer of the radar. On that computer, you remember the long cable at the end have two cables. One with the power positive and negative, and other with the data. In this particular example, the data is connected into the main screen, and of course the main screen is connected with the NMEA backbone. Okay, the power cable should be connected to a specific breaker in the sub panel with a fuse in order to protect the equipment. Check the fuse in the power cable. If the radar unit won't power on, remove the cable and check the fuse, inspect if the fuse is broken, and replace the fuse. It's too simple. All right, that's the first step when you have problems with the radar. The first step is verify if you have power. Okay, the first step is go into the sub panel, verify if you have power on the breaker, and after that follow the cable, check the fuse, verify if the fuse is in good condition, and follow the cables and verify if the power enter into the computer. That's simple, it's not complicated. Follow the positive line and the negative, of course, and verify if the power enter in the computer of the unit. Normally, the problem is the fuse is blown, or the ground. Once again, the ground, loose ground, corroded ground, bad ground, poor ground. Okay, this is the first step. The second one is clean the antenna. The antenna, the element, the rotor should be clean. Clean the antenna. If you notice a decline in the effective of the radar, probably is because those terminals on the sensors are dirt, or you need to clean the sensor periodically. The sensor is the element located on top, is the sensor that is spinning constantly. This is the sensor. Avoid use abrasive cleaners. Use basically isopropylic alcohol to clean the ends of the sensors. You remember I explained, the ends are plastic containers to protect the infrared sensors located inside. You need to keep that plastic with isopropylic alcohol. Never clean those terminals with acetone. Never clean those terminals with bleach. Clean those plastic terminals with isopropylic alcohol. That's the procedure. Alright, use alcohol in order to remove dirt. Review the antenna connections, okay, in order to verify if the interference is for loose connections or loose terminals. Verify the ground. Be careful with the ground of the antenna, especially the ground to the computer. The ground to the computer should be coming from the electronics group of batteries or house batteries, never from the cranking batteries. The cranking batteries introduce a lot of noise on the radar, and not only on the radar, on any electronic equipment. Never try to power the NMEA backbone from the cranking batteries. The cranking batteries have or produce too much interference, too much noise, especially during the cranking. In the moment of the cranking, introduce excessive noise and interference. Alright? This is very, 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 very important. If you have an open scanner like this, you should occasionally turn the scanner and verify that the mechanism, the electromechanical mechanism, is free. I recommend open the scanner like I explained before and verify that the belts are in good condition, properly tense, and the mechanism is turning in both directions easily. This is very, very important. And verify that inside of that box you don't have a box, you don't have geckos, you don't have any animals, any dirt. That area should be completely clean. Okay, check the display for moisture. Once again, the moisture is the enemy of all the electronic devices. The moisture produces a lot of inconvenience. And inspect the cable connection on the back. Always turn your electronics devices off before you check this equipment. Be careful with the generators. Be careful with the equipment that produce excessive electromagnetic interference. Be careful with those equipments. Okay, when you confirm a reduction in the normal target, you should verify the proper input voltage on the display and verify the ground. The ground is, in my opinion, the cause of 99% of the problem. Bad ground, contaminated ground, loose ground, improperly ground. And of course, fuses, because for some reasons, the power increased suddenly past the limit and the fuse is blown. The fuse is an important element. Never install in electrical or electronic circuits an equipment without the fuse. The fuse is according with the capacity of the equipment. I am going to install this equipment. Let me check the label. The consumption is 3.7 amps. Okay, the fuse should be minimum 5 amps. All right? A little over 10%, 15% over the maximum capacity on the label of the equipment. All right, and no rotation. This is very common that the sensor is not rotating. This is normally because the belts internally are broken, or because the ground is disconnected, or because the mechanism is broken. One of the gears internally in the mechanisms are broken. It's not common, but happens. Verify that your radar has completely the warm-up period. Normally, when you start the radar, take 20 seconds to warm up, and after that, start to move slowly. All right, this is the warm-up period, and normally is in between 20 seconds and 3 minutes. There are equipment like this one, Raymarine, is 2.3, 2.7 seconds before the sensor starts to move. All right, verify that is according with the manufacturer specific. Mr. Lopez said 20 seconds. No. I said it's in between 20 seconds and 3 minutes, depend of the manufacturer specifications. Check the manual, check the owner guide, and verify, okay, the warm-up time window for this equipment is 1.5 minutes. Okay, verify if that period is according with the catalog. Okay, with the radar off, check the antenna for restrictions. Manually rotate. You can rotate manually if the system is off. If the system is on, never try to move with your hand the sensor, because you can break the belt or the gears. Be careful with that. All right. If you have a dome, internally in the dome, you have the dish rotating 360 degrees. And the dome is a special plastic. That plastic allows that the rays enter and the rays goes out. It's a special plastic. That plastic is not an isolator. That plastic allows that the rays pass and bounces. All right? And the disc is rotating 360 degrees internally, like this disc with the mechanism that you have on the screen right now. If you have a dome antenna, remove the cover, the plastic, the cover, in order to access the antenna. Rotate it by hand. Check for broken belt. Carefully replace the dome and verify proper fit and seal. The dome in the bottom have an O-ring. Be careful with the O-ring. If the O-ring is broken, humidity enter in the system and produce erratic information, and corrode the computer, corrode the feeding with the cables entering in the computer. Be careful with that. All right. The other one is related with the information, loss of chart overlay feature. If your radar has a chart overlay and that mode will no longer operate normally, the problem could be loss of hidden information from the compass. Once again, we are going to return into the compass that we have on the screen. Where should be located the compass? In the center of the boat, as low as possible. In an area with zero electromagnetic interference. For that reason, that sensor should be located normally in the cabin, separated from air conditioning equipment, separated from water makers, separated from generators, alternators, engines. In other words, that element never should be located in the engine room. Should be located in the cabin, separated from air conditioning equipment. Where? In the center, as close as possible to the keel of the boat. In a dry area. No water, no humidity. In a dry area, as close as possible to the center of the boat. In a vertical position. In a vertical position. In a vertical position. Normally, if you open that sensor, I am going, that's the picture that you have on the screen right now. You have like a gyroscope. That gyroscope should be completely free. Yeah, this is the gyroscope that you have on the screen right now. Verify, move the gyroscope with your hand and verify that it's free. Okay, close again. Be careful with the seal. That's the seal that you have on the screen right now, that gasket. Be careful with the seal. Putting back the cover and verify that the sensor is in a vertical position. Follow the cable. Follow the sender in between the sensor and the computer. Follow the sender, the cable. Follow the sender and verify that the sender is not bended, it's not kicked, it's not broke, it's properly routed. Verify that sender, that cable is not close to the antenna cables, to the VHF antenna. Verify that sender is not close, is not together with AC cables, is not close to bonding lighting conductors. Verify that conductor is isolated from other sources of power. That's very important. It's critical for that sensor. For the same with the radar sensor, but specific with that sensor is very, very, very critical. Verify that the hidden device has power. Of course, that's very, very important. That device receives power from the computer. If it's properly connected to the computer, 100% sure that the sensor receives power and emits power. Okay, in some cases, the autopilot hidden sensor is used for chart overlay, and therefore the pilot must be powered on. Yeah, the autopilot should be powered on. For that reason, today the new boats, if the autopilot is turned on, the GPS antenna should be powered, connected, and the radar should be connected and powered. Okay, those three elements work together. Okay, and this is basically the information related with the radar. And right now we are going to talk a little about the satellite TV's antennas. Yes, the satellite is in constant communication with the antenna. Yeah, this is a low profile antenna for satellite TV. Yes, the same function that the big dome that you have on the screen right now. This is for a small boat, and this cable is connected here, and the other end connected directly into the computer into the computer or into the backbone, into the NMEA backbone, or into the computer of the main screen. This is the satellite TV antenna, and this antenna is in constant communication with the satellite. It's in constant communication. This is the typical low-profile antenna for a medium or a small boats. Antenna for satellite. What is the inconvenience of those satellite TV signals, the TV signals? Those signals, the transmission is excellent if the frequency of the signal is high frequency. For example, here, if the radio waves that are at high frequencies carry a lot of information, millions or billions of hertz, megahertz or gigahertz, but the inconvenience of those signals is that those signals only travel in a straight direction, in straight lines, no deflection. That's the inconvenience. For that reason, this antenna should be communicated with the satellite directly all the time, because it's a straight communication, a straight signal. This is the inconvenience of the TV signals, and the TV signals work excellent at higher frequencies, gigas or billions of trillions of hertz. At low frequencies, the signal is not good. All right, in order to spread those very high frequencies over large areas without any inconvenience with the curvature of the air, the antennas should be located as high as possible in your boat, normally in the radar arc or in the tower, at the end of the tower. That present two solutions. Use it in order to locate those antennas, at the end of the mast, if you have a sailboat on the mast at the end, and or at the end of the tower or on the radar arc. Those antennas should be located as higher as possible and separated from the VHF antenna. Okay, in general, on the arc, you have two dams. One dam for the radar and other dam for the satellite TV. I found that boats with three. The number 3 is probably other radar, or is probably a backup. But you need 2. One for the satellite TV and other for the radar, no more. And those are the typical location of the dams. One dam for radar, one dam for radar, other dam for satellite TV. The other one is spare, probably another radar, but this is the typical communication. This is the typical communication, and that small antenna is the GPS. That's the GPS antenna, and there are other VHF antennas, VHF, and other VHF. This is the typical boat. This is the searchlight. This is the searchlight. And what about those are cameras, more cameras. Excellent. This is the typical configuration of a boat.